Okay, a very good evening and assalamualaikum to our beloved lecturer and also my dear friends. So this is video for our lab 3, which is voltage regulators. Myself, my name is Nur Shahira Yusra from Tribank S3 and my friend Sun.
I'm Sun Yixiang from Tribank X3.
I'm Siti Nur Shafika from Tribank S3.
Okay, so as for for the third lab, which is voltage regulator, we have divided into 3 parts. So I'll pass for the first part to Sun for explanation.
So thank you, Shahira. So first, we would like to design for the OM series regulator. So open for this multi-sim. So this is a OPM series regulator. So we connect this circuit based on the lab sheet and using LM7419 741CN and the Zener diode BZX79C5B1. Okay, and also the BD135, and we connected into 4 resistor R1, R2, RL, R3, and power supply. And to look out for the Vout, we connect to a multimeter, and the reference will also connect to a multimeter. So our objective is to obtain a 10 volt output. So we are using the calculation first here. So to get the 10 volt output, so we assume that R1 is equal to 1 kilo ohm. So we want to get the value of R2. So I'm using this formula, V out equal to 1 plus R1 per R2 multiplied by V reference. So Vz is equal to the V reference, which is 5.1, the Zener diode value. Okay, so using the formula, we get R2 is 1.04 kilo ohm. So we set up here, R2 is equal to 1.04 kilo ohm, R1 is 1 kilo ohm. After that, we need to look out the value of the Vout and also the value of Vz. Okay, this is the value for 12 volt supply, and we get the output of 10 volt and 5.1 of Zener diode. So after that, we want to look at for the graph. So we go to stimulate. Stop first. Stimulate, analysis, simulations, and switch to DC swap. And we use the start value of 0, stop value of 40, and increment of 1. And output, we add the variables V in, V out, and V reference. Which from V out, V reference, and V in. Then we run. Wait that. This problem here. 140. Save. 8. Cannot show this.
Show just now.
8. Kenapa? Like this.
Try to open back your graph. I think just now we went to negative 40 already.
Where is it?
The output just now, the graph. The
Here.
run. And did you see the x value is negative 10?
Yes.
How to go right?
Oh, you got it. Please. Oh, yeah.
What was the mini? This LM.
Should we like delete the others first?
This
Maybe
one?
this one. Yeah.
Okay. For this, so this is a v in, v out, v reference. Just now we added the variables. So we are using the cursor one. So mean we look at for the x1 and y1. So the red line indicate the v in, the green line indicate the v out, and the blue line indicate the v reference. So means that, okay, when the v in is like 8, the v out will also like 8. But when the v in is 11, the v out maintain to 10. So the reference is 5.12. So if we increase, the v out will also maintain this around 10, and the reference also 5.1, and the v in is increased. So the output is maintained at 10 volt. So we obtain for the output is 10 volt. And we also find the values of v in from 2 volts to 20 volts, and we already record in the table over here. Yes, so this is a result that we get. Okay. So now I pass to Sharia for the shunt regulator.
Okay. I'll request control first.
Okay.
So for the shunt voltage regulator, this is the circuit that we use. So the difference from shunt voltage regulator and also the op-amp series regulator is that this one is actually the LM 741CN is terbalik, which is the opposite compared to the op-amp. As you can see from the op-amp series regulator, it's actually connected. The positive side is connected to the R3 and the negative side is connected to R1 and R2. So for this one, the shunt voltage regulator is opposite. So you can see here the negative is connected to the R3 while the positive side is connected to the R1 and R2. And also as it is shunt voltage regulator, we also added the RS here. And also instead of assuming R1 in op-amp, here we assume R2 for 1K as the calculated value is actually here.
Last one.
Okay. So this is the one. Okay. As you can see, this is the one that Sun explained previously, where we assume R1 for 1K to get a 10 volt. For my part is actually we assume the R2. So with the same formula that we use, we're gonna get the R1, which is 960.78 for ohm. So this is the by calculation. So we're gonna check with the simulation if it's actually correct. So same goes to what Sun done previously. So this would be the V out and this would be the V reference. So I'm gonna do the same, show the simulation first.
DC switch.
So everything is actually just same as what Sun said earlier. So I'm just gonna run this and look at the wave.
Yeah, this one.
Where's the wave? Okay. Sorry, Sun.
It's okay.
Okay, so for the one, this is the one. As you can see, gonna assume this the V in is 1 point. And then here, if 6, it will become 6.2 for the V out. And this is for, okay, for 12, V in 12, we're gonna get V out 10 and also V reference 5.1. Also, if we proceed to above 10, the value is still time 10 point something and also VREF maintain 5.1 until 20. Yeah, 20, we're still gonna get the V out is 10.01, which is round off get 10.1 and the VREF still maintain 5.1. So since we can't move it to get the exact value, we're gonna use multimeter, and then as the result, we already record it in here. This one. This is our results. So as you can see, most of the things we managed to get 4 until 20 V in, no, 6 until V in for 5.1 for the VREF, but it's just for 2 and 4 we didn't get the results as what we want, but as far from the others we succeed. Okay, that's all for Shan, and I think for the next part I'll pass to Shafika. Maybe you can request control first.
Thank you. Thank you, Shahira. So I'm going to explain about adjustable regulator. So for the LM317 adjustable voltage regulator, this is our circuit. So we use a capacitor in the V in and V out for the stabilization for our V out, and we use two resistor is constant resistor and adjustable resistor. For the value for adjustable resistor, we use a formula is V out of equal to Vref 1 plus R2 over R1 plus current adjustable R2. So for the Vref is a constant value 1 to 5, and for the I adjustable is 50 microampere. There is 50 microampere because we use a capacitor. So we get 8.269 kilo ohm. So we try to get the result here. We got 12.01 volt. So for the minimum volt here, we are 1.25, and the maximum volt is 12 volt. We use 20 volt because our V out is 12 volt, so V in needs to higher than V out. So for the simulation, same as what Sun have done it. DC. So we run it. So here our result. So we just see it S1 and Y1. Okay. So for the we can get that 12 volt at 15, and it will be constant until 20. Same as the result that we have here, 2 volt until 20 volt. So that's all. Anything?
Okay, thank you, Shafika, for the last part. So I guess that's all from our group 16. Nothing else to add on, right? Soon?
Yes, no.
Okay, that's all. So thank you to our lecturer. That's all from us. Okay, thank you. Bye.
Thank you.
Thank you. Okay.